Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we're looking at the UTME questions for chemistry for the year 2012. This is the first part of the recording. We are going to look at the first 25 questions in this year. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice UTME exam and modular quizzes for free. Our first question here is on paper type. Which question paper type of chemistry is given to you? In this recording, we are using the type red. Okay, the type red. Now, this question is it's a very important question. All right. You should endeavor to pick the paper type that corresponds to what you've been given. The paper type that you choose will determine how your scripts, your exam, will be marked. Okay, if you pick a wrong paper type, it means that your answers will be marked against answers that are meant for another exam, and that can greatly affect your results. Okay, so check out for the paper type that you are given. If you're using types, like there are different types, check out for the paper type that you are given and make sure that you choose that. Which of the following methods can be used to obtain pure water from a mixture of sand, water, and methanoic acid? That will be filtration followed by distillation. So filtration is going to remove the sand first because the sand is insoluble. Okay, the sand is insoluble in that mixture. So filtration will remove the sand, alright, while the remaining solution can then be distillated. Okay, distillation can now be used to separate the water from the methanoic acid because of the difference in the boiling point of water and how many atoms are present in 6.0 grams of magnesium? You have the atomic mass of magnesium as 24 and the Avogadro's number as 6.02 times 10 to the power 23. Alright, 1 mole of magnesium, okay, 1 mole of magnesium contains 6.02 times 10 to the power 23 atoms, and that 1 mole of magnesium is 24 grams. Okay, that's the atomic mass of magnesium, 24 grams. So it means that 24 grams of magnesium contains this number of particles. So the question is, how many atoms, okay, is 6.0 gram going to contain? So we say let 6.0 gram of magnesium contain X atoms. Okay, we will then set up a ratio. So we are going to have what we have here on this side, 24 over 6 is equal to this number here, the Avogadro's number, 6.02 times 10 to the power 23 over X. Then here 24 over 6 is 4, so we have 4 is equal to 6.02 times 10 to the power 23 over X. We can cross multiply this X here. If we cross multiply X, we are going to have 4X is equal to 6.02 times 10 to the power 23. Then to get the value of X, we will divide both sides by 4. Okay, so if you divide both sides by 4, you have 4X over 4 is X. Okay, 6.02 times 10 to the power 23 over 4. Now to do this division, what I'm going to do is divide this 6.02 by 4. 6.02 divided by 4 is 1.505. Okay, then times 10 to the power 23. This 1.505, approximately this is 1.51. As you can see, this 5 here is a number, up to 5, and numbers that are up to 5 and below, we round it up as 1 and add it to the number before it. So we round up this as 1 and add it to this is 0 here. We have 1.51 times 10 to the power 23. So 6 grams of magnesium will contain 1.51 times 10 to the power 23 atoms. Okay, this should be power. Next, on gas laws, 50 cm cube of gas was collected over water at 10 degrees Celsius and 765 mm mercury. Calculate the volume of the gas at STP if the saturated vapor pressure of water at 10 degrees Celsius is 5 mm mercury. So this is a question of volume, temperature, and pressure, and so we'll be using we are going to use the Charles law here. Okay, we'll be using the Charles law here. The reason why I'm using Charles law here is because the pressure here is constant. Okay, the pressure is constant, so we'll be using the Charles law. Okay, now the original volume of the gas is 50 cm cube. Alright, the pressure of the gas is 765 millimeter, but it was collected over water. and the pressure of that water, the saturated vapor pressure of the water, is 5 millimeter mercury. Now this saturated vapor pressure of the water has added to this pressure of the gas. That's why I have this 765 millimeter mercury. So if we want to know the actual pressure of the gas, we need to subtract the vapor pressure of the water from this. Okay, so we have 765 minus 5, and so this is 760 millimeter mercury. Now they say we should calculate the volume, that is the new volume V2, okay, at SCP. And at SCP, our pressure, the pressure at SCP is 760 millimeter mercury. The temperature is 273 Kelvin, okay, at STP. Alright, so you see that the pressure here and the pressure here is the same thing. That's why it is constant. It is the same thing. Okay, so there's no point using the general gas law, P1 V1 over T1 is equal to P2 V2 over T2. We don't need that, since it's the same pressure. The pressure did not change, so we just narrow it down to Charles' law. Alright, V1 over T1 is equal to V2 over T2. So what we are looking for now is V2, okay, the volume of the gas. So we substitute the other values that we have here. The initial volume of the gas, which is 50 cm cube, over the initial temperature. Okay, the temperature is 10 degrees Celsius. Alright, we convert it to Kelvin by adding 273, so we have 283 Kelvin is equal to the new volume over the temperature at STP, which is 273. Then we cross multiply. Okay, so if we cross multiply, this denominator here will multiply the numerator here, the denominator will multiply the numerator here, so we are going to have 50 times 273 is equal to V2 times 283. So 50 times 273 times 50 times 273 is equal to V2 times 283. To get the value of V2, I will divide both sides by this 283 to remove this. So I have V2 is equal to 50 times 273 divided by 283. By the time you multiply this and divide by 283, you'll be getting 48.23 cm cube. So this is the volume, okay, of the gas at STP. And what you have here is just an explanation of what we have done here. That because that gas was collected over water, the total pressure of the gas is going to be equal to the pressure of the gas plus the pressure of the saturated vapor, the saturated vapor pressure of the water. So like in this question now, the total pressure was 765, but the saturated vapor pressure of the water is 5 millimeter. So to get the pressure of the gas, we will subtract this pressure of the water from the total pressure. So 765 minus 5, 760 millimeter mercury. That is this. An increase in the pressure exerted on gas at constant temperature will result in a decrease in volume. Okay, so by Boyle's law, pressure and volume are inversely proportional at constant temperature. What that means is that provided that the temperature of the gas does not change, an ideal gas does not change, the pressure and the volume are inversely proportional, in the sense that if the pressure should increase, the volume is going to decrease. If the pressure should decrease, the volume will increase. So an increase in the pressure exerted on gas at a constant temperature will result in a decrease in the volume. Next question: in the reaction above, what volume of hydrogen will be left over when 300 cm cube of oxygen and 1000 cm cube of hydrogen are excluded in a sealed tube? So if we look at this equation of reaction, we will see that 2 moles of the hydrogen is what is required to react with 1 mole of oxygen. What this means is that whatever volume of oxygen we are using, we need 2 times of that volume of hydrogen, okay, for this reaction. Whatever volume of oxygen we are using, we need 2 times that volume for the hydrogen. Now in this question, if they are using 300 cm cube of oxygen, it will mean that the volume of hydrogen that will be needed will be 2 times that 300, that will be 600. So it means, so out of this 1000 cm cube of hydrogen that is now used, it is only that 600 theoretically that will be used in this reaction. So the remaining hydrogen is now going to be 1000 cm cube minus the 600 which is used, so we have 400 cm cube. Next question on matter: which of the above can correctly be listed as evidences for the particulate nature of matter? So what we call the particulate nature of matter is the property of matter, okay, as a function of particles that it contains. That is, we are saying that what we are saying when we say that matter is particulate is that matter is made up of smaller particles, okay, and the way these particles are, the way they are arranged, the way they move, okay, is what would define the property of that object of matter, okay. Now, evidences that can be used to support the particulate nature of matter include diffusion and Brownian motion. Okay, they can be used as evidences to support the particulate nature of matter. Also, these phase changes, this evaporation and sublimation, they are processes that are involved in the change, okay, from one phase to another, that is from one state to another. For example, evaporation is the process of a phase change, okay, from liquid to gas. Sublimation is from solid to gas. Okay, these are not direct evidence. They are not direct evidence for the particulate nature of matter. Okay, they are not direct evidence for the particulate nature of. If the elements x and y have atomic number 11 and 17 respectively, what type of bond can they form? A simple way is to actually define these elements here. Which element in the periodic table has the atomic number of 11? Okay, if you read the element, your hydrogen, helium, lithium, beryllium, like that. The 11th is what? Is that is sodium, right? That is sodium. While the 17th is chlorine. The bond between sodium and chlorine is ionic, is an electrovalent bond, where this one electron in the outermost shell of the sodium ion of the sodium atom is transferred to the chlorine atom, so that both of them can have 8 electrons in the outermost shell. Okay, and that's one by they attaining octet structure. Okay, having 8 electrons in the outer. A hydrogen atom which has lost an electron contains, so an hydrogen only contains one proton and one electron, no nucleus. Okay, one proton and one electron. That is the protium. Okay, the protium, it contains only one proton and one electron. So if it loses an electron, then it only contain a proton. Okay, it will just become a proton. This is for protium, which is just an isotope of hydrogen. We have deuterium and tritium. Okay, deuterium is another isotope of hydrogen that has one proton and one neutron. Deuterium is another isotope of hydrogen that has one proton and two neutron. In those cases, if the electron is lost, so you still be left with the proton and one neutron, or the proton and two neutron. That is in with other isotopes of hydrogen like deuterium and tritium. But for protium, okay, which is like the most times when we're talking about hydrogen, we are referring to protium. Okay, unless stated otherwise, we are actually referring to protium. It contains one proton and electron, and if an electron is lost, you are going to be left with just a proton. The electronic configuration of magnesium, okay, magnesium ion is, now the original configuration for magnesium ion. Magnesium has 12 it has what's it called, 12 electrons. Okay, 12 electrons. So if you write the electronic configuration, we are going to have, using the SPDF notation, we have 1 x raised to power 2, 2 x raised to power 2, 2 p raised to power 6, 3 x raised to power 2. Okay, by the time you add up these powers here now, 2 plus 2 plus 6 plus 2, you'll be getting 12, which is the atomic number of magnesium. However, this Mg2 plus here indicates that this magnesium here has lost 2 electrons. Okay, it has lost 2 electrons. So instead of 12 having 12 electrons, it now has 10 electrons. So this 2 is not here again. This 3 is out. So this will now be the new configuration. Okay, where the number of electrons now is now 2 plus 2 plus 6, and that is 10. Okay, as we have it here. Alright, group 7 elements are, they are monoatomic. Okay, they are monoatomic. They have an oxidation number of -1. Okay, they require only one electron to attain the octet structure. That they are in group 7 means that they have 7 electrons in the outermost shell. So to attain octet structure means to have 8 electrons in the outermost shell. So for them to do that, since they have 7 electrons already, they need one more electron. Okay, they need one more electron. So they are monoatomic with a valency of -1. Which of the following is used to study the arrangement of particles in crystal lattices? That is the X-rays. Okay, X-rays are used to study the arrangement of particles in giant molecules and crystal lattices. Which of the above shows that air is a mixture? So, from the properties of a mixture is that it is going to have varied composition from one place to another. That is, its constituents are not in definite proportion. So, the proportion will vary from one place to another. Also, its constituents can be separated by physical means like evaporation, like distillation, centrifugation, sublimation, like that. It can be separated by physical means because they are physically combined, they are not chemically combined. Unlike, for example, in water. Okay, the chemical formula for water is H2O, right? The hydrogen and oxygen in that water, they are chemically combined, so they cannot be separated by a physical process. Okay, but in the case of mixtures, okay, the constituents are physically combined and as such they can be separated. Next, that it contains unreactive noble gases. That is also correct. Okay, that is also correct, that the air contains some rare gases. However, I would want to say that the word unreactive may not do justice to the noble gases. Okay, under certain conditions, so they do undergo reaction, but they are largely unreactive because of their octet structure. Next, the chemicals used to soften hard water involves the addition of soluble compounds of sodium. Okay, soluble compounds of sodium that will form insoluble precipitate of the calcium and magnesium ion in that water. Okay, so it is the calcium and magnesium ions in form of thiosulfate or thiazocarbonate that are responsible for the hardness of water. So to remove them, you need to use soluble compounds of sodium that will form insoluble precipitate of those calcium and magnesium ion. That's why we use things like washing soda, okay, and caustic soda. Alright, these are soluble compounds of sodium, okay, that will form insoluble precipitate of calcium and magnesium ion. Chlorination of water for town supply is carried out it is for disinfection, okay, to remove the germs from the water. Next question on solubility. The solubilities of different solutes in a given solvent can be compared by. So to compare solubilities of different solutes in a particular solvent, okay, in one given solvent, we can plot their solubilities on the same axis. Okay, we use a solubility curve, which is a graph of the solubility of those substances. Okay, it can be for just a substance. Okay, so it will be a graph of the solubility of a substance against temperature, but you can also use it for more than one substance. Okay, for easy comparison of their solubilities. Okay, provided it is the same solvent, the same medium that those substances are being dissolved. Next on solubility, potassium thiazochlorate 5 has a solubility of 1.5 mole per dm cube at 45 degrees Celsius. On cooling this solution to a temperature of 20 degrees Celsius, the solubility was found to be 0.5 mole per dm cube. What mass of potassium thiazochlorate 5 was crystallized out? You have the atomic masses of potassium, chlorine, and oxygen. Okay, so the mass of the solute that will be crystallized is going to be equal to the difference in the solubility, okay, the difference in the solubility times molar mass. That is the solubility at 45 degrees Celsius minus the solubility at 20 degrees Celsius multiplied by the molar mass of potassium thiazochlorate. So what we need to do here is find the molar mass of this potassium thiazochlorate. That is going to be the sum of the atomic masses of the elements that we have in it. So you have the atomic mass of potassium 39 plus that of chlorine 35.5 plus 3 times the atomic mass of oxygen, which is 16. So by the time we evaluate this, 3 times 16 is 48. 39 plus 35.5 plus 48 will give us 122.5. So this is the molar mass. So you can go back to using this formula now. The mass of the solute at is equal to the difference in their solubility
that is solubility at 45 degrees Celsius, which is 1.5, minus the solubility at 20 degrees Celsius, okay, multiplied by 122.5. This is going to give us 1 here. 1 times this will just give us 122.5 grams. Next question: which of the following pollutants is associated with brain damage? That is radioactive fallout. Okay, radioactive fallout and heavy materials can cause cancer or nervous disorder when they get into the body.
You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below.
Which of the following will produce a solution with pH less than 7 at equivalent points? So 7 is the neutral, is the pH value for neutral substances. Anything above 7, okay, from 7 to 14 is, above 7 to 14 is alkaline, is the pH of alkaline substances. Less than 7 to 1 is to 0 is for acidic substances. Okay, so the question here is that which of these, all of this that we have here, they are reactions of an acid and a base. So they are saying which of these is now going to produce a solution. Okay, when you get an acid with a base, you get salt and water. So that means that these reactions there, they will give us a solution of salt. So which one would have will produce a solution that will have a pH less than 7? That is, which one is going to produce an acidic salt from these reactions here? And that is the reaction between the hydrochloric acid and the magnesium hydroxide. Okay, because the hydrochloric acid is a strong acid, reacting with a weak base, okay, a weak alkali like magnesium hydroxide is going to produce an acidic salt because the acid is more concentrated. The number of hydrozonium ion produced by one molecule of an acid in aqueous solution is its. That is what is called its basicity. Okay, its basicity. So when acids, when they ionize in water, they either produce hydrogen or hydrozonium ion. Okay, if it is a strong acid, it will produce hydrogen ion. If it is a weak acid, it will produce hydrozonium ion. The number of the replaceable hydrogen ion per atom, the number of replaceable hydrogen atom per molecule of the acid is what is called. During a titration experiment, is 0.05 moles of carbon dioxide is liberated. What is the volume of gas liberated? Alright, 1 mole of carbon dioxide is 22.4 dm cube. So is 0.05 moles, which is what is liberated here, is going to be equal to 0.05 times 22.4, and that will be 1.12 dm cube. A major factor considered in selecting a suitable method for preparing a simple salt is its solubility in water. Okay, there are 2 factors that are considered, okay, in the choice of the method to produce a salt. One is the solubility of the salt, okay, the solubility of the salt, and the second is the solubility of the base that we are using to produce the salt. The solubility of the salt in water, and the second one is the solubility of the base that is used in producing the salt. The oxidation number of boron in the given compound here is, alright, so to find the oxidation number of boron here, we are going to equate the sum of all the oxidation number here of the atoms here to is 0. Okay, the oxidation number of the compound, is 0. Alright, so we will now equate the sum of the oxidation number of each of the atoms that you have here except for this boron to 0. So you say the oxidation number of sodium is +1 plus the oxidation number of boron, let's just leave that as B, plus 4 times the oxidation number of hydrogen. Now usually the oxidation number of hydrogen is +1. However, in this compound here, in an hydride here, okay, the hydrogen here is acting as an hydride, and in hydrides the oxidation number of hydrogen is -1. So you're using -1 instead of +1. Okay, so you have -1 is equal to 0. So you have 1 plus B, 4 times -1 is -4 equals 0. 1 minus 4 is -3, so you have B minus 3 is equal to 0. To get the value of B, we then bring -3 to the other side. So you have B to be equal to +4. +3. Next question. The substance that is oxidized in the reaction above is. So the oxidized substance is the substance that is reduced. Okay. The substance that is the substance that is oxidized. Okay. And that will be the reducing agent. Okay. We have what we call oxidizing agents and reducing agents. The oxidizing agent is the substance that brings about oxidation and it itself becomes reduced. Okay, it brings about oxidation but it becomes reduced itself, while the reducing agent is the one that brings about reduction but it becomes oxidized. So in this question they are asking us to find the substance that is oxidized. It's the same thing as finding the substance that brought about reduction, like the reducing agent. Okay, and in here it is the water here. Okay, it is water here that is the oxidized substance here, or the reducing agent. How is it the reducing agent? Because it is the one that has donated this hydrogen here, okay, to sodium. It has donated this hydrogen. The removal of hydrogen is what is reduction. Okay, the addition of hydrogen, the addition of hydrogen is reduction. Okay, removal is oxidation. So it has donated this hydrogen to sodium here. So what has happened there? It has reduced this sodium. Alright, I think this is just a simple way to put this. So it is reducing this sodium. Now as it is reducing this sodium, it is now becoming oxidized itself. Okay, or you can think of it as this is the substance from which hydrogen was removed. Okay, this is the substance from which hydrogen was removed. So the substance from which the removal of hydrogen is oxidation. So that means that this is the substance that is oxidized. Okay, that is oxidized to oxygen. Finally here, what number of moles of copper will be deposited by 360 coulombs of electricity? Okay, the oxidation number of copper is +2. That means that to deposit 1 mole of copper, we are going to need 2 Faraday of electricity to deposit 1 mole of copper. The 1 Faraday of electricity is 96,500 coulombs. So 2 Faraday is going to be 2 times 96,500 coulomb. So you have 193,000. It means that to deposit 1 mole of copper, we need 193,000 coulombs of electricity. Now if you are now using 360, okay, 360 coulomb of electricity, then what is now going to be the mole, the number of mole of copper that you are going to deposit? So what we are going to do is we are going to set up some sort of ratio here. Okay, 1 mole of copper requires 193,000 coulombs of electricity. We say let the number of mole that this 360 coulomb will produce, let it be what? X, capital X. So we say X mole of copper will be produced by 360 coulombs. So we then set up a ratio taking the sites, relating the sites of the expressions that we have here. So we are going to have 1 over X is equal to 193,000 over 360. So we have 1 over X is equal to 193,000 over 360 is 536.11. We will then cross multiply here. Okay, we are going to cross multiply. So you use this X to multiply this here. So we are going to have 1 is equal to 536.11 X. Okay, to then get the value of this X, we divide both sides by 536.11. Okay, or just say switch the position of this X and this, that is, switch the position of the denominator on this side and the numerator on this side. So if you switch that position, you are going to have X, that is, X will come and become numerator. This one will fall to this place here as denominator. So you are going to have X to be 1 divided by 536.11. and that will give us 0.00187. In standard form, okay, if I shift these points here to the middle here, I'm going to have 1.8 times 1 2 3 10 raised to the power minus 3. The reason why this is negative is because this is a number less than 1 that we are dealing with here.
Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at ScholarFedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.